Okay.
Are you ready? Good?
Yes, that's perfect. It's very
Okay.
nice.
So, first of all, would you walk us through a day of what happens in Cascade Prosthetics?
Sure, this is it. It varies from day to day. Fortunately, we don't have a whole lot of clientele coming in today. The snow has canceled a couple of people, and it's cold. But usually, if it's a new patient, we'll run them through an assessment, and then we'll take a cast, either a hand cast using plaster of Paris bandage or a composite, or I also have a machine, a water bladder machine, that allows me to take a cast under weight bearing for especially transtibial amputees. So we'll go with a total surface bearing cast that captures the shape of the residuum under load, because the bones, the tissues tend to stretch differently. So up until that, we always used to take a hand cast, person would be sitting and there wouldn't be any load. So I have the only system of its type in Alberta, and only the second one in Canada, that takes the impression under load. So that gives us a cast, plaster bandage cast that we fill with plaster of Paris, and then we will modify it slightly to accommodate what we want. And this is a check socket, or these are check sockets, and this is an alignment device. This is plastic, comes in a round disc. We heat it up, pull it over the cast, blister mold it, and that becomes the sockets. If they're good, we'll laminate them with an epoxy or an epoxy acrylic, and make the definitive from there. So that's what goes on day to day. It can be a leg, it can be an arm. Okay, got a couple of arms. We repair them as well as fit them, so we'll make cables, make harnesses. Or yesterday we were fitting this leg for rotation plasty. So it's making sure the joints are right, and that it doesn't move the person's foot either way as they bend. So everything it just depends on the day and the patient.
Okay.
So, all right?
All right. So I have a question regarding, so it states on your website that you're a vendor for big companies like APS and
Yeah.
Letterbach. So you do the sockets in-house?
We do the sockets in-house. So
Okay.
everything that fits the patient, we do in-house. Everything like the knees, the feet, the joints, that type of stuff, we buy either from Autobach, Orthoped, Oser, Miradol. There's about 3 or 4. APS, I don't mess with that. That's more for really custom hand and foot and leg cosmetic recreations. So I was the first in Alberta that started using APS, and they send an artist up here. I'll take the molds of the person, say if it's a hand, I'll take the mold of both hands, send it down to Connecticut, and they have their artists make a mock-up of it, and then create a clear silicone device, which the artist then comes up and paints on the inside to match the person right here, to match their skin coloring and everything like that. It's really worked out well, better than I could ever done. So they do that. The people that have them are incredibly happy. I just had one go out the door the other day. Otherwise you could have seen that, but people can't tell. So the one guy that we've got a hand for, he's missing all of his fingers, basically at the knuckles, and he always used to keep his hands in his pockets, and now it's part of his life. He shows it up. People don't know that he's an amputee, so it works that well.
So it affects the patient's receptiveness of wearing a prosthesis?
Oh yeah, yeah, definitely, because it looks like their hand. It's got they put hair in it. They put all the folds from the knuckles, the fingernails. Everything's custom painted. It's not cheap, but it looks amazing. Like really, I've had people almost cry when they've seen it when it's on. So that's why I use them, and that's all APS does, and they go all around North America doing that.
So APS is the only. So you don't do any custom aesthetic prosthesis in-house. It's usually with APS.
if it's a partial hand or a partial foot amputation, yes. Otherwise, for the regular transtibial and transfemoral, like that cosmetic covering, we'll do in-house.
Okay.
You may buy it, we buy the foam and shape it down, that type of stuff. That's kind of a low definition cosmetics. The really high definition is for the hands and the feet. People really, you know, they really like the results of having it look natural. That's just more than what we can do. But all the other aesthetics we'll do in-house, unless it's something like this. That'll be a custom fairing over top of a person's transtibial prosthesis. So that gets made in Vancouver, and then we'll
That's awesome.
we'll put it on. Yeah, it looks really, people have been really pleased with that.
So how significantly would you say the custom aesthetic prosthesis affects the price? Ballpark figure, it's like 3 times the price.
Yeah, I mean, it's for the standard type of prosthetics that we do, it adds maybe $1,000 to $1,700.
1,000.
Yeah, but the really high definition stuff, that's anywhere from 10 to 15,000. So that'd be 5 to 6 times what the AADL program would pay for it. And that's the expense, because that's all time, labor intensive.
So just because we're interested in how, you know, the population, how much they're willing to pay in order to have, you know, something that looks more lifelike. So would you say a lot of people opt to have the custom aesthetic?
Yeah, that's a small number of the clientele.
Okay.
But the ones that they do, if they have insurance, they opt for that. I had a woman in here about a month or 2 ago, and she's just missing half her thumb, and that was about $4,000. So they had insurance, and I don't think she's taken it off since.
Wow.
So yeah, she couldn't believe, she sat in the waiting room afterwards just staring at both her hands with the thumb. So that was pretty wild.
That's amazing.
Yeah.
But
aesthetics aren't necessarily important to everyone.
Yeah.
I have some people that leave the pipe exposed, or will have knees like this for snowboarding and all that. They leave those exposed.
Okay.
So, and when that guy wouldn't get that much, that would be what his prosthesis would look like. Now we can do different patterns like this. I mean, because it's a liquid resin that we use to do the lamination, it's just a matter of putting a fabric in.
Yeah.
And then it gets, then it becomes part of the prosthesis. So a lot of people tend to like that. And I have quite a number of different fabrics, but I'll just go to Fabricland, or people will bring in a shirt, and we can incorporate that into their prosthesis. I thought I had a bunch around, but I think we moved them.
Okay.
I think they were moved on.
It's okay. Do you do any carbon fiber prepreg in-house?
I don't.
Okay.
I'm not equipped to do the prepreg.
Okay.
Because that's a whole different process, of cool and vacuum stuff like that. And I don't like using carbon fiber, just personally.
Is it toxic?
Well, I don't know if it's toxic. I've heard the fibers sort of embed themselves into your lungs a
Yeah.
little bit more than,
Yeah.
you know, other fibers would.
Yeah.
So we just have local ventilation here. So you see the
okay.
people that deal with carbon fiber a lot, be it in the auto industry or knee bracing and stuff like that, they're all in the full sort of Scott air suits. We don't have that. I will use a fiberglass and a basalt reinforcement that is a lot like carbon fiber, that is as strong as carbon fiber. It's just supposed to be safer. So I'll use that, but I don't really mess with the carbon fiber or the prepreg.
Or the prepreg.
Or the prepreg.
What about 3D technology? Do you see it?
It's coming.
It's coming?
It's coming. There are a number of sort of central fast places that will 3D. And I'm playing around now with the little structure scanner. And in fact, those covers there, the one I showed you before, they're 3D printed. So it's coming. I don't have a 3D printer. I've probably won't get one for a bit, although Hewlett Packard now has a different type of 3D printer that will make a socket that's strong enough, because up until then, they haven't really been strong enough to walk on.
Yeah.
But I think that's changing rapidly.
So,
it'll be coming.
okay. So your opinion is that it will be successful?
Oh yeah.
Okay.
You know, but what will determine the success really is who programs the shape, how you capture the shape, and how you manipulate that shape in order to form the socket, because everything's custom made to the person. I noticed a couple of your questions were, what's the best socket, what's the best this, and there really isn't.
Okay.
Okay, because everything is all custom made to that individual. And depending on how they lost their limb, be it trauma or vascular, you know, what their age is, it's gonna all be different. So we have to, after we take the plaster cast, we manipulate that. So my plan is to sort of scan that cast then and do my modifications on a computer, and then it can go to a 3D printer, or the orthotist next door, he's got a couple of robots, well, one milling machine and one 7-axis robot, so it carves out a foam, so that's an option too. It's a different learning curve with those, but yeah, I think it'll be here to stay.
Yeah.
It seems to be the wave of the future until something else comes along, but so I can see definitely getting into it at some point, and possibly for the sockets. It depends on the materials and how much you want to spend for a printer. I do know there's an amputee, he's down at MIT, he runs his own gait lab there, Hugh Herr.
Herr, yeah.
Yeah, Hugh Herr. So he's printed up some sockets for himself that, as a result, so his scanning machine, he's got a weird kind of machine that measures the shape of the residuum and the compression of the tissues. Because tissues compress differently over bone and over, as opposed to muscle. So his machine will take about 45 minutes to read that. And then he 3D printed sockets for himself that were rigid, where the tissues were plastic, and you know, soft where the tissues were rigid. He claims the most comfortable sockets he's ever had, but he designed the machine and he did all that, so I wouldn't expect him to say anything different. And the sockets are also pretty thick, so I think that may be coming down the road. That would be ideal if we could get, if it could 3D print a material that's more sort of biomimetic, because even with his machine, it doesn't take the impression under load, and it doesn't totally take into account how the tissues change through the range of motion. So stumps change as they bend as you're walking on them. So if at some point you could have a material that would mimic that, would be ideal. We've played around with some different stuff from other manufacturers, but I haven't found that yet.
Oh, so you don't use any shape mapping softwares? So it's
Not yet.
Not yet. Okay.
It's out there. CAD.
Yeah.
But you still have to capture that shape somehow. You have to get that shape into the machine.
Yeah.
And if it's scanning, what I haven't totally liked is scanning's totally not under load at all. So that doesn't reflect really the tissue. I've liked doing a hand cast, because then I can push in, I can manipulate that tissue the way I want. And now with the water casting technique that I have, it puts an even pressure over the whole surface of the residuum, and that captures that shape better. Now, whether I scan that afterwards, after it's cast, or there is a machine that will digitize that, it's like 60 grand, so I'm not about to buy it. But you know, it's all how you get that shape into the, you know, into your mapping software. So if you can pressure map the whole surface of the stump
Mhm.
when a person's walking, that would be ideal. I haven't seen anything that will do that yet.
Mhm.
There's something close, but it just measures sort of different points on a socket, and then it doesn't do anything with it. Just it's up to us to do stuff with it. So things are changing. I mean, it will, you know,
Mhm.
20 years from now, if people aren't regrowing legs or if osseointegration hasn't overtaken everything,
Mhm.
I can see big things.
That was one of my next questions. How do you feel about osseointegration? In terms of
I think it's great for a narrow population
Mhm.
that it fits right now.
Mhm.
I think the last I heard was the surgeon down in Australia has probably done about 400 to 500 of them,
Okay.
and it's really good, but that's worldwide.
Mhm.
There's millions and millions of amps, so not everybody is a candidate for it. You know, a lot of older diabetics with the brittle bones,
Mhm.
you know, if that goes bad, if
Yeah.
osseointegration goes bad, you're looking at either a hip disarticulation amputation or an above knee, you're looking at going higher,
Mhm.
right above. So it'll improve like everything else too. It'll be interesting to see where it goes. Here in Canada, we can't keep up with the number of hips and knees in our healthcare system, replacing hips and knees to
Why is
add
that?
something else like this, because it'll be the orthopedic surgeons that do it. I don't know that healthcare necessarily has the money, or whether or not they want to pay for the componentry that's needed. So there'll be things that will have to be worked out here, but it's also, I don't know, I've always felt if surgeons took more time and greater care, edit this part out, doing the amputation, then we wouldn't see as many of the socket problems as we do. Half of the pain problems I think that are resolved by osseointegration are just resolved because they're plugging that bone and they're restoring the intermedullary pressure that normally exists in a bone that's lost when you just cut the end off. So even if you just cap the bone, you would probably see, you know, far less pain in amputees than we're seeing now. So,
And it solves the whole issue of phantom pain a little bit.
well, I don't know what'll solve the issue of phantom pain.
No.
You haven't figured out
No.
phantom pain
I
yet?
haven't figured out phantom
Oh,
pain.
Steve, I thought
Nobody
you were on that a
has.
while ago.
And I don't know that it necessarily would,
Mhm.
because phantom pain is a whole different animal altogether.
Mhm.
And there's no rhyme or reason to who seems to get it.
Mhm.
There's no rhyme or reason when they get it. Some people theorize that the change in air pressure brings it on.
Mhm.
There was a family of surgeons down in the States that believed that what you needed to do is sort of separate the vascular bundle, the vascular supply from the nerve supply. Because what happens is when the barometric pressure changes, the cells swell or shrink, and if they swell too much and your nerve's too close, then it's going to be the beating of the heart that bangs on the nerves that causes the phantom pains.
Mhm.
Some people believe it's pain is your body's way of saying, hey, look at this area,
Mhm.
right? Once you cut it off, then it's not getting the input that it needs, so it still gives you that, you know, look at this area type of thing.
Mhm.
There's a lot of different theories about phantom pain, and that's a whole other
Scope.
scope, yeah.
Okay.
Okay.
Do you have any questions, Joel? You good? Okay, so it seems like funding is an issue when it comes to the technological advancements that happen in prosthesis. So do you work with the University of Calgary on any research, or perhaps the government?
I haven't. I've worked with some of the larger corporations, like Autobach, and that had an interface group, and I'd be part of that. But I haven't worked with the university. I should probably look and see what options are there. But we haven't yet. And yes, money is a big issue when it comes to the higher technology. A lot of this stuff is funded by the government through their AIDS the Daily Living Program, and their mantra is that base mobility only, and they think of these other things as sort of Cadillacs and don't really need to pay that type of money because it's more than what the person really needs. When in reality, you know, the Cadillac is what we're born with, and anything, no matter how technologically advanced, is a poor replacement at best and just a tool. So it is, I mean, some of these knees can cost $100,000. That's a lot for people, but the amount of mobility that it restores is phenomenal, and the quality of life that it gives an individual allows them to basically live their lives again. That's often overlooked, you know.
Yeah.
So yes, money is a barrier to some of the technologies, and the government doesn't like to fund backup or recreational prostheses. So if you used to snowboard before your amputation, well, do that. You've got to buy something like that. That can be $5,000 or $6,000.
Okay.
Right. So
yeah,
even with workers' compensation, they don't necessarily pay for recreational stuff because they believe it's just the things you need to get back to work. So there's that's a big barrier, because basically every above knee amputee could probably benefit, if they're mobile at all, could probably benefit from a microprocessor knee. That they don't have to think about where the knee is, that the knee's always interpreting the input data to make sure the leg is safe. So that's, but it's pricey. I mean, they're gonna start about $40,000 and the government may kick in $6,000. It's a big gap.
Big gap, yeah.
Big gap.
Yeah. So on the website it mentions that you use software apps with the C-Leg and the Genium. So how's that looking like? Or how do you teach patients or new amputees how to use it? Is it
I use it.
You use it?
They don't necessarily use it.
Okay.
Although there are now apps for the phone that will allow them to adjust different aspects of the gait within limited parameters. So how I use the software is to basically program the whole knee. All right. If it was one of the old sea legs, we would program in the parameters of when the knee would break, when we want the knee stable, how the heel rise, how much we want heel rise, when we want the hydraulics to start engaging on swing through so they don't get a terminal impact. All of that stuff. If it was a Genium or an X3, I have a few things that I can set, but basically I use that to confirm the alignment, because the sensors in the knee then communicate with my computer to show me where the ground reaction forces are, and the shear forces on the sole of the foot. So even though I think I've got it aligned just right, I go by that visual cue just to confirm that, and then we can set a few things after that. Set second modes or third modes, because that gives a number of options if they want to run, if they want to, stand, it has lock mode, initiate. We can set up the optimized physiological gait type of software, which is sort of a learning software that optimizes their gait. So that's how we use the software. Now, the clients can do a few things. If it's not keeping up with them enough, they can adjust maybe the swing through, but it just allows them a few adjustments to make within whatever parameters I set. So that's where the software comes in. It's the same for some hands. They can program the modes of the hands through the software, and then they can do it through their app as well.
Is it actually possible for us to see like a demo of the hand, maybe?
Oh yeah, that one's just charging. So this is one of the newer versions of the hand. So this is a myoelectric prosthesis. So this is where technology is changing as well. For probably ever since the late 70s, we've used 2 electrodes to pick up antagonistic muscle groups. And so we need about a 5 microvolt signal to either open the hand or sort of close the hand. This one, we can change grip patterns, unless I just turn it off. So he can work that finger or stuff like that. We can also get rotators to put in here, but basically it's you sort of extensor muscle groups open the hand, flexor muscle groups close the hand. what's coming out, or a dual contraction will switch it to rotation, and then it becomes, extensor muscle groups clockwise, flexors counterclockwise, or vice versa. What's coming out now is pattern recognition. So with hands like this, even though there's motors in every finger, you can't really control them all. You can't do this, you do that or that. With pattern recognition, instead of just the antagonistic muscle groups from 2 input sites, we'll use 11 inputs and a ground, and it will capture the EMG signal at any point in time. So the hand will run through a calibration. You can set up however many motions you want, and you try and mimic those motions with your sound hand, and the pattern recognition captures that snapshot from those 11 or 8 electrodes and says, okay, this pattern means that. So it's a lot more intuitive, and it can get a lot more finer control. So you can then end up with just changing the grip patterns by what you want to do, instead of having to hit a button or co-contract or change the programs that way. And now there's a new electric wrist that will allow simultaneous rotation and hand function. So that's coming. We're a long way from the Luke Skywalker hand, but this is getting better all the time. Although this isn't the best hand out there, but so that's available, and that's how this works. Just off of, it picks up 5 microvolts, less with pattern recognition, amplifies it, draws the power from the batteries, and the hand does what you want it to do.
How often do you have to charge it?
Every day.
Okay.
So it really depends on battery size and how much it's used. It's like a cell phone.
Okay.
Right. So, but a battery should last at least a day.
At least a full day.
At least a full day.
And what's the learning curve on a hand like this for, say, a new patient that's
for a new patient
just using something like this?
With the dual electrodes, it's you should be able to be functioning with it within about a day or 2. It's still, you've got to learn these unnatural motions, and you've got to learn how to differentiate the signals, because the hand is basically, even this is an on or off, right? So whichever signal it gets first, it's going to do. So we usually spend a couple of weeks beforehand going over how to isolate the different movements, so you don't have that much of a signal leakage, or if you do, the signal that you don't want is less, and that the signal you want hits the threshold first. With pattern recognition, it seems to be almost instant, because it's so intuitive. It's, if you want to do that, you do that. It records the pattern, and you do that. It can calibrate on the go. There'll be a little calibration, button on the arm. So if you're working normally down here, but you want to change lights and your hand doesn't work as good, you recalibrate it for where you're at. So they learn pretty good. And actually, I've got to apply. This guy's WCB, so I'm going to talk to them about switching him over to pattern recognition. So I think he'd do very well. So that's coming up. That different type of electronics is coming up. And in addition to microprocessor knees, we're getting microprocessor feet. Some powered feet are looking at coming on the market within probably the next 2 or 3 years to help push you through. Hugh Herr has also come up with his own powered feet. He had his own microprocessor foot first. I don't have a sample of it here. And he had his own. He came up with microprocessor knee that, unlike Autobox, that adjusts the hydraulic cylinder to control the knee. His uses a real magnetological fluid and changes the viscosity of the fluid to change the function of the knee. So they're 2 different. I don't use that many of the Oser ones. I like the Autobach ones. The C-leg was actually first designed up in Edmonton. And it's because of the way it's set up. If you ever run out of battery, or if you ever short out, the the default position of the knee is stable, so it doesn't really bend. You walk around like peg leg. Whereas with the Osser knee, because it relies on applying a magnetic field to the fluid to thicken it up, the default there is basically a free knee. And the beauty of a microprocessor knee is you can put that knee in an unstable position, which makes it easier to walk. And the microprocessor, the electronics take over with the stability. So when they're not there, you've got an unstable knee. So I've tended to shy away from those. Because that's always been a challenge with the mechanical knees, where to place the knee. You know, too stable, the person doesn't fall, but then they don't walk that well. You know, if they wanted to walk well, it's closer to an unstable position relative to, you know, basically an arbitrary ground reaction line force that we come up with. So, you know, if your real magnetic knee goes free and it's unstable, that might not be a good thing. So I've tended to shy away from it. They're good knees otherwise, and that's just my preference. So you can ask all the other prosthetists in the city and they'll probably each give you a different answer as to what they like.
That's true.
Yeah.
Just looking over the questions, we appreciate the level of detail you've given us in all of your answers. So what are some technologies that Cascade hopes to implement or challenges it hopes to eradicate?
Well, I will probably look at some way of implementing CAD or 3D printing or robot carving sometime in the future. But I'm still very much, I mean, I've been doing this since the mid-70s, so my hands tell me what I need to know, and that's more than any scanner can. And probably expand a little bit more with the hydrostatic casting machine that I have. So what I have right now is just passive. I let the water back in, close the petcock, and have the person stand on it. But I can hook it up to a water supply and actually get to a prescribed pressure, which is, I have an app which tells me, enter the person's weight, their circumference and MPT without a liner on, and that basically tells me how many bar of pressure I'm looking at, or I want to achieve. So with the water supply one, I could actually get to that. With this, I don't. So, but so far it's been good. I've got a learning curve with it, but
of course, yeah. I think you've touched on almost all of the questions.
I have a question. So, talking about specifically like the technology side of these prosthetic devices, what would you say, like say the last 10, 20 years, what would you say the most important developments have been in terms of the technology?
Probably been in socket design. I mean, the feet are feet, everybody's got feet. Knees, you know, the microprocessor knees are great, bits of control. But when I started doing this, it was still the veterans, you know, I made a few wood legs, which is basically just sort of carve out and have an open end. We still saw a number of veterans with sort of open-ended sockets and basically just a plug fit. So now we're getting into different things like ischial containment, where we'll put pressure on the ramus and the subtrochanter in a transfemoral or above knee amp. But we started to think more about the whole total surface bearing, trying to put as much weight over everywhere as opposed to just a specific weight bearing. So I think that has changed a lot of stuff, because it's changed how people think about what they're doing. Start taking different parts of the anatomy into account, instead of just, here's the cast, you do this, you do that, and you make your leg. So everything's a lot more customized, a lot more specific to the individual's needs, the individual's physical circumstances, life circumstances. So that is probably, to me, the biggest change, is how we sort of look at that. Now everybody's thinking about, you know, the shape of the socket, and they're not just doing assembly line factory stuff. Now that could change more with the computerization, because there will be templates and there will be, you know, you'll just go, okay, well, this is that fits that, away we go, right? People are like that. Some people are, it's very cold, don't slip. Some people are, you know, I mean, I've often talked with the reps from Autobach and like the sea legs, even the earlier versions of the sea legs, they have to go in for repairs every so often. And I think he said 90% of them come back with the same settings that they left the factory at. So people just, if it's there and it's easy to do, they'll do that easily, right? So that's down in the States. Up here, they don't necessarily see that much. But that would be my fear. So if now you've got a computer screen that says, you know, this should be that should be that, the temptation to go, yeah, okay, you know, and it may fit 80% of the people just great. But the other 20% you'll have problems. So that would be a fear, you know, that things get too easy.
So I guess my last thing is, because we're interested on how this prosthesis technology affects society, could you comment on how it improves the quality of life of people and how it affects their ability to work and their mental health?
Oh, it's huge. So not only, first off, is body images. I mean, we're a very body image conscious society, right? You can't walk through a store without seeing magazines that have been airbrushed a certain way. So just having a prosthesis, having 2 feet, having 2 hands, helps to go a long way to ease that. But the technology, the way it's incorporated, does give people back their lives. So I had another client, when I first saw him, he was having problems. He couldn't take his leg off and put it on the same day. With mechanical knees, he would fall. He didn't want to do anything because he wasn't sure if he'd, you know, end up on his butt or whatever, if his friends would laugh. He's got a microprocessor knee, an X3, and it's awesome. He got it so he could carry his daughter down the stairs. He goes up and down the stairs. He doesn't worry about it. He walks everywhere. He does everything. He goes to the gym. It's phenomenal. It's really given him a level of freedom and given him his life back. Have another amputee that's below the knee. He's trying to see how strong he can get going to the gym. He goes back, he works on the rigs, he's a foreman, so he contributes to society. He's got a bunch of kids. And this allows people to get back and to work. Now, if you're 70 years old and you lost your leg through, you know, diabetic vascular disease, you might have been retired before, so you're not going to go back to work. But just by being able to stand up and move around, that exercise helps delay the natural progression of the disease and reduces the amount of readmissions into hospitals. So it pays a big dividend to society throughout, because now people remain independent, and so they don't need other care. They can work. They don't go to the hospitals often. It's incredible. And you've probably passed a load of people in the malls that have been amputees, like not all at one time, but over 15 years, and you've never noticed it because they're just out doing what they're doing. If they don't have a cane, they don't, you know, off they go. So there's a lot of people that keep working, and